Problem 3. The corner plate of the hull of a ship shown is curved on the arc of a circle with 1.5 meter radius. With submersion in seawater as shown, compute for a 1 meter length perpendicular to the sketch the amount and location of the horizontal and vertical components of the total pressure on AB referred from point A. So let's have this curve AB. Let's concentrate on this. So the radius of this arc is 1.5. This is a quarter circular arc. And this is again an imaginary rectangle. So this is case 2 where the liquid is below the curve. So the vertical component is upward this time. So we draw horizontal line through the endpoints of the curve. Then that's the net height of the vertical projection of area, which is 1.5 meters high by 1 meter width, because we consider 1 meter length into the screen or perpendicular to the sketch. And FH is located below the centroid. It is acting to the left. This is the centroid, and the distance of the centroid to the line of action of FH is vis-a-vis, and that is vis-a-vis. And we will call this YA because we locate FH from A. Then FV is upward. Instead of locating FB by means of centroid of composite areas, we use Varignon's theorem because this is again a circular arc. The resultant passes through the center of the arc, which is at O. So for FV, it is equal to the weight of imaginary liquid bounded by the vertical lines through the endpoints of the curve itself, and the real or imaginary seawater surface, which is this. So it consists of quarter circular arc plus rectangle again. So first for FH, specific weight, barred H area, specific weight of seawater, 10.06. Barred H is 2.7 plus half of 1.5. That's F, which passes through O, and call that XA. So FH is specific weight of seawater. Barred H is 2.7 plus half of 1.5 to reach the centroid of projected area, and the area is 1 by 1.5. So FH is 52.06 kilonewtons. FV is specific weight times volume, or specific weight of seawater. Volume is quantity area of quarter circle, which is pi over 4 or 0.25 pi radius square, plus area of rectangle 1.5 by 2.7, then times length perpendicular to the board, which is 1. So FV is equal to 58.52 kilonewtons. Next, we solve for ISA V, which is height of rectangle square, 1.5 square over 12 barred H. And barred H is 2.7 plus 1.5 over 2. So ISA V is 0.05435 meter. Therefore, YA is 0.75, half of 1.5 minus ISA V. So YA is 0.75 minus 0.05435. So YA is 0.6956 meters. So we say that FH is 52.06 kilonewtons, and it is 0.6956 meter above A. For XA, instead of locating the centroid of composite areas, we just use Varignon's theorem that moment about O is 0, the moment of the resultant is 0, and it is equal to FV times XA, which is counterclockwise, minus clockwise moment FH times 0.75 plus ISA V. This is 0.75 plus ISA V, moment arm of FH from O. So minus 52.06 quantity 0.75 plus ISA V. So solving for XA, XA is 0.7156 meter. So we say that FV is 58.52 kilonewtons, and it is 0.7156 meter to the right of A. So that's it.